Record, share screen. Oh boy, what have I done? Okay, so for question number 28, we had established yesterday that when you roll 3 dice, there are 216 different things that can happen. Is everyone comfortable with that? That was 6 times 6 times 6. Honestly, this is a pretty unscientific process, but if you want to know the different ways that the dice can sum to 6, the only way to do that is either with 1s, 2s, 3s, or 1s, 1s, and 4s. So if you think about it, like, and I tried to be pretty organized about this. I said the first die could be 1 and the second die could be 2, which leaves the third die having to be 3, right? Those obviously add to 6. And then I also thought, well, I could swap the back 2 dice. Like the first one could be 1 and then it could go 3 and 2. And in keeping with this theme, I said, well, maybe the first die is the 2 and then the next ones go 1 and 3. Or maybe the first one is the 2 and then the next ones go 3 and 1. Or maybe the first one is the 3, 1 and then 2, or 3 and then 2 and then 1. When using these numbers, 1, 2, and 3, these are the only ways to put them in different orders. So far, we've counted up that there are 6 ways that 3 dice could sum to make 6. But the problem is there's another way too. And that is you could build it out of 1s and 4s. And so if you think about it, I could get a 1 and then a 1 and then a 4. Or I could get a 1 and then a 4 and then a 1. Or I could get a 4 and then a 1 and then a 1. So at this, oh, I forgot about that one. What if all 3 of them are 2s? Thank you. I could do a 2 and then a 2 and then a 2. How dare I overlook that one, right? Did we miss anything else? I don't think so. So now you just have to count them all up and yeah, thank you for that. So when you add them all up, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you just reduce that down and it comes down to, if you divide them both by 5, no, excuse me, divide them both by 2, you get 5 over 108. So that's that. Yeah, that's 28. That's number 28. We hadn't finished it yet yesterday. So any questions on that? Thanks for catching the twos. I would have just spaced those out. So, all right, I'm sorry. So on to the second batch. So this is where Monday's quiz will kind of start. So I'm going to walk through and again, if I go too fast or whatever, just cut me off, slow me down, raise a question, whatever, I don't care. 7 people being arranged for a photograph can be as easy as just making your 7 chairs. So there's another way to do this too, but I'm just going to go 1, 2, 3, 4, 5, 6, 7. And this thinking will get you through a lot of this test just to say, okay, those are the 7 chairs. And when there's 7 people in a pool of like candidates, I just pick one and I have 7 to choose from. But as soon as I place one, then I don't have 7 anymore. I only have 6. And then once they're placed, I have 5 and then 4. You get the idea. And we know another name for this. It's, of course, another name for it is 7 factorial. So you can type it either way into your calculator. You could also even type it in if you were some kind of weirdo as 7p7, which all 3 things that you see on the board are, I'm telling you, identical. And they're all going to come up with the answer 5,040. Hard to believe that with just 7 people that you can arrange them 5,040 different ways. It's like, it even makes sense. Pretty cool. For question number 30, there are 2 ways to do this problem. And again, I'll show you. So here is the seat in which the president will be seated. Here's the seat for the vice president, and here's the seat for the secretary. When I begin this process of nomination or election, there are 18 people that could win the presidency. So I put 18 there. But once someone is elected president, there are only 17 who could be vice president. And then that leaves only 16 for secretary. And that's it. Another way, though, to do that, more like a cool way to do it, perhaps like a more slick, fancy way to do it, would be to say I've got 18 people and I'm doing permutations of them 3 at a time. And if you have discovered where the NPR and NCR buttons are on your calculator, then this is maybe a quicker way to do it. I mean, yeah, either way you do it, this is going to take you 7 seconds. I mean, 5 seconds maybe to type it in your calculator, 3 or 4 seconds to write down the work. So maybe 10 seconds. Yeah, Micah, you're exactly right. 4,896 is correct. So any questions on that one? Okay, question number 31 is going to be just basic, very, very elementary, simple counting principle. If Mark has 5 pairs of shorts and 7 shirts and 3 pairs of shoes, assuming he picks one of each and makes an outfit out of it, you just multiply those together and he has 105 different outfits he can make. That's just counting principle 101. That's the sandwich problem again with the bread and the meat and the cheese. Okay. Question number 32. The key word here is committee. And what you need to understand is that generally by default in a committee, there's really no, the order of it is not important. Like if I just said I need a committee of people, I'm just picking some folks. There isn't like a president and a vice president unless it's specifically mentioned, right? So the right. And so that's kind of our indicator. And you could put that on your page of notes for tomorrow, or in this case, maybe for Monday. But remember that the word committee lends itself to order does not matter. So this is not a problem where you can draw blanks or anything. This is just straight up this. There are 13 people. I'm doing combinations of them 4 at a time. And as we saw, remember, if you still have your Pascal's triangle laying around, that means you could go down to the 13th row of Pascal's triangle and across to the 4th element. But honestly, it's not much slower, assuming you know where the C button is on your calculator to just type this in. And if you don't know, you're running out of time, come see me. If you shouldn't be using a calculator on a phone because you can't do that on quiz day anyway. So I'm assuming you have some sort of TI something 30 or a Cassie, and they all have this functionality on there. So when I type in 13C4, I get 715. So if there are 13 people in a room and Mr. Dishman walks in and just basically says, listen, I just need a group of 4 of you. There are 715 different groups that he could pick, not worrying about order with the people. So, and then of course, we also have to think about number 33. And listen, I have to have faith by the time you're in 11th and 12th grade that you read English well enough to know the context of when does order and when does order not matter. So when you read question 33, it's your job to say, I don't think order matters. Plus it says combinations right in the freaking problem. So, I mean, says it right there. So this isn't about like trying to arrange the questions. This is about just picking a group of 5. So straight up, when you're showing your work on a problem like this, you should have 9C5 because there are 9 questions on the test. And my teacher said I can just pick 5. And the answer to that is 126. And that wraps up page 3. Any questions there? Okay. Question number 34 starts us out on page 4. And this is, again, a combination problem because order doesn't matter. If you're playing cards with someone and you guys have all played cards of some sort before, what's the first thing you do when you pick up your cards in any game? Bridge, you put them in your own order. Like you do with them what you want. So like the order that someone deals them to you in is completely irrelevant. So this is a combination problem all the way. And it's just this, it's 52, choose 5, 52C5. And it's really big. It's 2,598,960. I will say this again because I repeat myself. Just it's a necessity of this line of work. If you don't know how to do C's and P's on your calculator, you really should let me help you before it's too late. You did 52P5. No, it wouldn't be the same answer. It's not possible. It would be 120 times larger than this. So it would be like 250, 60 million. Not even close. It's impossible that those would come out the same. For question number 35, order does matter. And the key word for me here was schedule. I feel like you might take the same classes as your friends, but that doesn't necessarily mean that you have the same schedule. Like the schedule should imply to you that order matters. So when I set this one up, and I assume when you set it up, that you set it up as 12P7. There are 12 classes, but you're arranging them in schedules 7 at a time. The arrangement aspect is what tells us it's a P, permutation. And that comes out to also very large. That's 3,991,680. Questions there? Ms. Roscoe, you good back on 34? Got that all squared away? Question 36 is just straight up, how many options are there multiplied by how many times? I mean, if you really were some kind of workaholic, you could write out the whole 12 question multiple choice test. You could go 1, 2, 3, 4, 5, 8, 9, 10, 11, 12. But again, there's this thing called an exponent that someone decided to start using this shorter notation a long time ago. But the key here is that every one of these has 5 options. There are 5 options for the first question. There are 5 options for the second, and so on and so forth. So the more concise way to write this would have been 5 to the power of 12, which is also very large. 244,140,625. I mean, you can imagine if you were a teacher and you gave a multiple choice test and 2 kids sitting next to each other turned in the same exact test, you could very strongly make a case that they cheated and that, you know, there's a 1 in 244 million chance that you got the same answers, right? So question 37 is just the blank, blank, blank. Really, you could shortcut this one, but it's almost not even worth the effort. The lock has the numbers 0 through 59. And do remember, everybody, that the number 0 through 59 means that there are 60 numbers, because 0 always adds that extra annoying one. So when you're doing a combination, you just have to ask yourself, can the numbers in the combo be repeated? And it says, sure. So that just means I do first turn, second turn, third turn, and each turn has 60 options. And so that comes out to 216 with 3 zeros. So 216,000 different combinations are possible in a lock like that. Question 38, and this is Barney, the boneheaded bank robber. And the thing is with Barney, he's like, oh yeah, I don't know the combo, but I'm going to sit here and guess it till I get it. Barney's an idiot, first of all, right? So if you can do a combo every 10 seconds, then that directly implies that you can do 6 every minute. Is everybody at peace with that? And if you can do 6 every minute and you multiply that by 60, since there's 60 minutes in an hour, then that implies that you can do 360 per hour. And of course, there's 24 hours in a day, so you would multiply that by 24, and you would figure out that Barney can guess, if he stays on task and doesn't get, you know, arrested or whatever, he can guess 8,640 combinations per day. But the question, I mean, he'd have to be methodical about it. He'd have to go, okay, I'm going to try 0, 0, 0. And then he'd say, okay, I'm going to try 0, 0, 1. And then he'd have to try 0, 0, 2. I think he'd have to be pretty methodical. But like I said, he's an idiot, really. Clearly, hence his name. And then you figure out, oh God, my God, if he's got 216,000, he's got to check. So what I set it up, had used my calculator, obviously. I did 216,000 total combinations divided by how many he can do per day. And honestly, I didn't mean for this to happen, but it came out to dead perfect, exact, no decimal, 25 days. I'm sorry, say it again. Very much so, yeah. I'm sorry. Sometimes I feel like I don't know why I think you should just know that, but yeah. Any questions on that one? Barney's obviously not going to guess the right combination. I mean, unless he gets lucky on the first try. But if he were to have to try them all, it would take him 25 days. I'd like to think so. Never mind. Yeah, I'm getting so much better at filtering myself. 39, a single die is rolled 4 times. So as soon as someone says that, I don't even read the rest of the problem. I go like this: 1, 2, 3, 4, boom, done. So that's me rolling the die 4 times. And then I just have to go through and fill in the blanks. Okay, so my bossy teacher on the first die wants me to roll a factor of 10. And the factors of 10 are 1, 2, 5, and 10. But 10's not on a die, so there are 3 of those. My bossy teacher also wants me to roll a multiple of 3. And there are infinitely many multiples of 3, but the only ones that appear on a die are 3 and 6. Remember, multiples are like counting by that number: 3, 6, 9, 12, 15. So there are 2 of those. And then my bossy teacher also wants a prime number. And we have had this conversation, and you might want to hear me say this. You had better have on your notes before Monday the definition, maybe even before tomorrow, the definition of a prime number. We've been down this road before. But, you know, maybe as a courtesy to Edie or anyone who wasn't here that day, let's remind ourselves of what prime numbers are. To be a prime, what are you? What do you have to be? You got to meet a very certain criterion. That's a good way to say it. I mean, but the problem with that is then people say that one is a prime. To be a prime number, you must have, and I'm going to caps lock my pen here. I just clicked caps lock and here it goes. You must have exactly, I'm going to take off caps lock now, exactly 2 factors. One and yourself, which is why 1 is not a prime number. 1, contrary to popular belief, is neither prime nor composite. He's just 1. It's a guy. It's a dude. So to be a prime, you have to meet this one rule. So the first prime number in existence is 2 because his factors are 1 and 2.
Wait, but that's making 1 0.
No, because 0 has infinitely many factors. Everything is a factor of 0. 54 times 0 is 0. 1 million times 0 is 0. So on and so forth. And it's not like we haven't had this. So this, you're not hearing this for the first time. 3 is a prime number because his factors are 1 and 3. 4 is obviously not a prime. 5 is a prime because his factors are 1 and 5. And 6 is obviously not a prime because he's got 1, 2, 3, and 6. He's got too many factors. Someone will still find a way to miss this. Don't let it be you. Got it? Let it be someone else. How many prime numbers are on a die? 3. Right? Their names are 2, 3, and 5. So if my teacher says, I need you to roll that die and I need it to come up as a prime, the prime options are 2, 3, and 5. And that is exactly 3. Got it? On the 4th die, my bossy teacher says, hey, I need you to give me a factor of 24. And there are a lot of factors of 24, but the ones that are on a die are 1, 2, 3, 4, and 6. There's more. There's 8 and there's 12 and there's 24, but those are never on a die. And so I'm only listing these because those are the ones I could come up with, and there are 5 of those. This is not a quick problem. This is a roll up your sleeves and plan to spend a minute or 2 on this one. Right? You just go through it meticulously one by one. So here it goes. I multiply these together. 3 times 2 is 6, times 3 is 18, times 5 is 90. So if I sat Trinity down and gave her 4 dice and said, okay, I need you to roll me a factor of 10, a multiple of 3, a prime number, and then a factor of 24, there are 90 different ways that she could accomplish that task. That's what that means. On then we go to question number 40. And so I've got these numbers to select from. I've got this bank or this hat full of numbers, 4, 0, 3, 5, 8, and 9. And someone says, I need you to write me a 3-digit integer. So 2, 3, like this. Look at the bank up there. How many numbers could I put in the first spot? Good answer. Why not 6, Aubrey? Right. I mean, to be and again, we've had this conversation probably a half a dozen times. It's nice that Edie gets to hear them for the first time, but the rest of you guys, we've talked about this. To be a 3-digit number, you can't start with 0. Like 042 is 42. It's a 2-digit number, right? So to be a 3-digit integer, you can't start with 0, which leaves us with 5 choices. Now, no one cares what the second number is, right? It can be anything. So we're back to having 6 choices. And the last number, we're back to having 6. Right? Like the number could be 588. Like it could be 888. Just that first one is the only one that has a restriction on it because it can't be a 0. And that comes out to, 180. All right, question number 41. In the state of California, there are a lot of different license plates possible. So you obviously need a larger potential pool of plates when you have a massive population like California does. So in California, their license plates have 7 blanks, or 7 characters, I should say. So we have 1, 2, 3, 4, 5, 6, and 7. These are pretty straight for free. The first one has to be a number. However, if you read on a little bit, the first number is not allowed to be a 0. Like I looked that up online. Like I didn't make that up. That was on like the California Department of Transportation website. You can't start a California plate with a 0. So how many things could the first character be? 9. 9. Because remember, the digits are 10 of them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is not a digit, you guys. 10 is a 2-digit number. A digit is one of these. But remember, when you add 0 onto a list, there are exactly 10 digits. However, if some bossy person says you can't start with a 0, then you say, well, I have 9 from which to choose. You can't start with a 0. I have 9 choices. Got it? Like you really got it? Okay. Now the next 3 are unrestricted. There's no rule of the law or the law of the land that says anything about the next 3. It's a free-for-all. So it's just 26 in every one of these blanks because there are 26 letters in the English alphabet and there's no law that says they have to not repeat or anything like that. So they're all 26s. And then the last 3 are all digits and there are no restrictions on what the last ones can be. It could be 0, 0, 0. It could be 409. It could be 910. There are 10 options at every step along the way. 10, 10, 10. Remember, the only time you modify the 26 and the 10 when you're doing these license plate problems is if you have a reason. Someone says like, you can't use the same letter twice, then the numbers get smaller, or you can't use a 4, then you take 1 out, something like that. But it's a lot. So this is how many license plates are possible in the state of California. And when I typed this in, I got 158,184,000 plates. So there are that many plates possible in the state of California. Are you texting?
No.
Okay, good. Thank goodness. Oh, your phone's right there. Okay, I'm sorry. So the follow-up question is for 42. I just was looking for something a little bit more fun and challenging for some of you guys that find this stuff pretty easy. This is a good problem-solving sort of situation. So, and I did also look this up on the internet. I could not get current data for the year 2023. Honestly, the closest I could find was the vehicle registration data from 2021. I only spent like 10 minutes looking, but still. So in 2021, there were actually 14,268,000 528 vehicles registered in the state of California, right? If 1.5, and I also looked this one up too. I used some averages to predict this, but I did a little bit very simple loose math and figured out that on average, California can expect 1.5 million, aka 1,500,000 new vehicle registrations every year, right? Whether that's a kid getting a car for his birthday or someone buys a car on Craigslist or something. But there's that many new ones every year. So my question to you is, how long will it take before California runs out of license plates? So the math of it to me was pretty simple. I took the 158,184,000, and I subtracted the number that are currently on the road, and I came up with 143,915. And if by some chance this is still making sense, here's my logic. There's a buttload of license plates possible in California's system. Only 14,268,528 are currently in use, right? So if I subtract the ones that are currently in use, I'm left with a buttload still. And then I took that buttload and I divided by the number that are new every year, that are predicted to be new every year. And I came out with around 96 years. So, I mean, California's like, they're not going to run out of new, unique 7-character license plates for another almost 100 years. And if they did, like, let's say they had this crazy influx of population and that 1.5 million went up and they ran out in 30 or 40 years, then all they'd have to do, how could they fix their problem? Add another character. Just say, let's add another letter. Boom, you multiply it by 26, you're good for another Lord knows how many years. So simple problems to fix. But you see that California is not going to have any issues with license plates for a while. Good. On to then the back page we go, and that'll leave us hopefully with a little bit of time, maybe, where I can go over any other questions you might have, more probably on the first half, since that's the half you have to do tomorrow. So I'm gonna bring this up here because yeah, but I won't do it right. I can't. Not right. Let's not have that conversation right now. Okay, let's talk a little bit. So I made this problem up last year and I was like, this is a weird problem, I better keep it. So the Velvet and Leather Guitar Showdown, where contestants have to either play acoustic or electric guitar, but they're forced to wear either leather or velvet pants, which is really weird, I know. Anyhow, let's answer some questions. So for question 43, what's the probability that a randomly selected contestant was dressed in velvet pants and played acoustic? Yeah, did that not do the trick? Did he seriously? How'd that not work? I got coffee here, so be careful. Make sure you throw it well. He went right for the coffee. Look at that. It's like, you guys are like magnetically attracted to the one spillable object on my desk. I should have known. You can't sleep during. I threw something at you and it hit you, and you just can't do that, bro. Like, I know you're gonna do fine on this quiz, but it doesn't work. It doesn't work that way. So this is an and problem, and problems, I hope, if I've done my job even remotely well, this word right here, and I will say on the quiz, I bolded and underlined these just to take one last shot, and should be like a real treat. This is where I'm just looking for one select set of numbers that's at the intersection. So velvet and acoustic is right here. If you're in that group of 6 people that I just circled, you are wearing velvet pants and you are playing an acoustic guitar. So before I begin, I need to go through and count the table up. An 8, 5, 13. I count a total of 22 in this table. So the first thing I did was write down 22 as my total. Do you not have this with you? Are you guys okay? Is it just this section right here that's getting squirrely, or is that everybody? Do we need like a 2-minute break or something? We're good? We okay?
What do you mean?
I got Sergeant Slumber over here. Doesn't even his practice quiz on his desk. He's sleeping like it's freaking 2 in the morning. Everybody else okay? You still with me back there, Lawson? Listen, I don't know what that means, kid. Can I do anything for you? Oh, sorry. Trinity, how you coming back there? You're still with me? I hope. Swaggy P, you good? Ulysses S. Slumber, are you okay with it? All right. You still waking up from the nap, aren't you? You're groggy. I'm like when your mom wakes you up from a nap and starts telling you to do the dishes. I'm that guy, except I'm not your mom.
Do you not take a nap during Lultings? Do you not take a nap during Lultings?
All right. Well, with that little sidetrack done, let's get back to it. So problem number 43 is just very, very quite simply, there are 6 people that meet the requirement out of 22 in the table. And assuming that you have been here and listening and following directions, your job at this point is to take on your calculator and divide 6 divided by 22. And the decimal that pops up on your screen is it's 0.272727. And if you move that decimal 2 places to the right, you should get exactly 27.27%. And do not listen. I don't know why they don't teach this at a younger age. If you put this on there, it is no longer rounded. That is not a rounded decimal. A rounded decimal does not get expressed with a repeating sign. A rounded decimal is you saying, I'm going to chop this bad boy off. So this is 27.27%. I'm not saying that there's anything wrong with 27.27 repeating. It just, in this case, there's something wrong because you're just not following directions. Question number 44 says, what is the probability that a person was dressed in leather pants or played an electric guitar? And if you still are not on the, I know how to do that bandwagon, let me try again. We're going again. Here it goes. The word or is the kicker. Or, huge. So it means I got to count up first just the leather pants people, and that is 13. They are all in this row right here. There are 13. So I'm going to write the number 13. And then I also have to add to that the people that play an electric guitar, and they are where this purple arrow is pointing right down here. Those are all electric guitar people, and there are 8 of them. And for the 24th time, why can I not just do 13 plus 8 and just stick it over 22? Because some people got counted twice. You guys are the best. Good. So there are people at the intersection of where the red arrow is pointing and the purple arrow is pointing. I'll be quite specific with you. It's these people. They got counted twice. You're like, hey, I can either be counted as a leather pants weirdo, or you can count me as an electric guitar player, but don't count me twice. So we take the 13 plus the 8, but we subtract those 5 weirdos. What is 13 plus 8? What is 21 minus 5? So the answer to this problem in its I'm ready to roll format is 16 over 22. And again, there's no benefit to reducing it because like you're going to make it into a decimal percent thing anyway, so who cares? So just type in 16 divided by 22 in your calculator, and it will be 0.727272. I want to take a look at this with you. 0.72727272, and then so it's probably ends. I don't know where it ends. But the point is this. If you move that decimal 2 places to the right, you get 72 point what? 72 point what? It is not 72. Yes, you have to round up. And the key with rounding is always remember this. And take this with you, free of charge. This is on the house. If someone says round to a certain place, here is what you do. You draw a wall right after that place and say, come hell or high water, there's going to be nothing after this wall. Now, what you have to do is look one place past the wall. What's right past the wall? What's the next number after the wall? And that 7's like, hey, I'm going to boink up that 2. I'm going to make that 2 go up to a 3. So that's why this has to be 72.73%. Good so far? You hanging with me? Dope. That leads us then to question number 45, which is what's the probability that someone blah, blah, blah plays an acoustic guitar? And look, again, you do this on IXL. Given that they were dressed in velvet pants, what that does is it shrinks the denominator. If it's given that they wore velvet pants, basically all these people now that wore leather are dead to me. They no longer exist in this table. So the new bottom of the problem, the new bottom is 9. There are no longer 22 people at the table for this problem. And I just want to know what's the probability that they played an acoustic guitar. How many of those 9 weirdos played acoustic? So the answer is 6 out of 9, which of course then you would put in your calculator or not if you can do it in your head. It's 2/3, which then is 0.6 repeating, which is 66.67%, because that's 6 rounds, the 6 before came up to a 7. We good there? All right, let's press on. We're almost there, guys. The last one is, I don't know what this is all about. I just was looking for something like butterflies and yeah, I just grabbed the first one I saw and I just ran with it. So Isabel designs bow ties for the local boutique store. And there you go. So this is a 2-way table because the ties are being tracked 2 ways by their material and by their shape. 2 ways, 2-way table. So what is the probability that a randomly selected bow tie was made of cotton or in the shape of a bat? Are you whistling at me? You're not doing that. Were you whistling just now? God, don't do that. Come on, man. If I got any shot at getting through this, I can't have you singing, whistling songs. I got Sleepy over here. Whistling at me. Lord. I'm going to have to delete this recording. This hasn't been smooth. I changed the order of these, and so this time I put the or one first. And again, on the quiz, this will be bolded and underlined so you cannot miss it. The ors are the ones where we add and subtract. So how many are cotton?
Television.
Good. And how many are batwing?
No.
Batwing.
Okay.
Good. Now the question is, how many are both? And at the intersection of the both is there are 6 right here. Those 6 that I just circled are cotton batwings, and so they have to be taken out because they got counted twice. So we're going to do 11 plus 10 minus 6, which is 21 minus 6, which is 15. One thing I hadn't done yet is count up the table, but I did do it yesterday. There are 18. So 15 out of 18. If it were a fraction problem, you'd totally reduce it to 5, 6. But as I said a couple minutes ago, who cares? You just type it in and it does come out to 8. If your calculator will say 0.83333333333, which no fancy stuff here, right? 83.33%. And you don't round up because there's just a 3. Like 3s don't change stuff. Question 47 is the given problem. So the effect of the given is that we shrink our denominator. So if it says given that it was made of suede. So all I do now is I keep the suedes and I say cotton bow ties, you're dead to me. I need you to take that approach. I need you to think that way and say if it's a given problem, the ones that are not included in that disclaimer statement thing, get them out. Okay. So my new denominator is now 7 because there are only 7 that are suede. Of them, how many are in the shape of a butterfly? So the answer is 3 out of 7, which when divided and properly rounded comes out to 42.86%.
How'd you get around the times?
5's round, 5 is counted as a mover. I don't remember what my calculator said, but 5 is a changer. 5 and higher rounds up. 4 through 0 keeps the same. And lastly, question 48. This is going to be obviously an and because it's the one I haven't used yet. So this right here, what I'm going to circle is an implication of and. Like if it says it's a suede batwing, it of course has to be suede and a batwing. So I just simply look for the intersection of suede and batwing. It's not very hard to find. It is right at the 4. This right here. If I'm in that little red circle, I am made of suede coming down this way, and I am a batwing shape coming this way. And so to be a suede batwing, there is a 4 out of 22, 4 out of 18, excuse me. I forgot which table we were on. There's a 4 out of 18 chance of picking that. So,
It is 22 points.
right. I don't know if you guys, some people are just so not interested in this kind of stuff, but I just thought I would show you some. Oh, but yeah, so the answer is 22.22%. I can give you little life hacks. So here it goes. Here's one on the house. You ready for this? If you're in things like this, are they useful? I don't know. Maybe. Do you guys know what 5/9 is as a decimal? It's 0.5 repeating. Isn't that amazing? Like, did anyone ever tell you that before? How about this one? What do you think 2/9 is as a decimal? It's 0.2 repeating. Isn't that amazing? If you think about it, like think about 3/9. That's 0.3 repeating. But if you reduce it, you get 1/3. But there's more. I realize some of you are acting like we're done here, but there's more. I've got more free gifts for you. If the bottom of your fraction is an 11 by like this, you ready for this? I think stuff like this is amazing. You take this only works if the bottom is an 11. You take the top and multiply it by 9. What's 4 times 9? 36, right? And so the answer to this one is 0.36363636. Isn't that amazing? So like what would say like 7/11ths be as a decimal? 63 repeating. I don't know, maybe you already knew that, but I think that's pretty cool. So like that's how sometimes on some of those we are able to do them a little bit quicker. So is there anything else on, since you have to take the first half tomorrow, is there anything on, like for your practice quiz that would mean this? Anything on the first 2.5 pages that I can explain to you again or go over with you again? You guys good? You sure? Okay. Well, tomorrow I don't have it like printed and photocopied yet, but at this point, instead of 28 questions, I believe the first half is going to have more like 22 or 23. Just FYI. So you want to give it a shot tomorrow? You just see how it goes?